If I say, what is the square root of 4? What's the answer to that? Well, when you see that symbol, that little hook there, it says find a non-negative, in this case a positive number, that if you multiply it by itself, the answer is 4. So what positive number times itself is 4? 2. What's the square root of 9? What positive number, if you multiply it by itself, is 9? That's a 3. What's the square root of 16? 4. 4 times 4 is 16. What is the square root 25? 5. What is the square root of 36? 6. What's the square root of 49? 7. What is the square root of 64? 8. What's the square root of 81? 9. Notice the answer is always positive. What's the square root of 100? 10. The only time the answer is not positive, I forgot to write the square root of 1. That's 1. So the only time your answer is not a positive number when it's 0. What's the square root of 0? 0. That's not a positive number. That's why we say find a non-negative. It can't be negative. It's either positive or 0. When it's 0, the answer is 0. But otherwise, the answer is always positive. If we give you a number that's not one of those numbers, then you have to go to the calculator. So if we said to you, what is the square root of 56? You go, 56? Let me see. Oh, that's not here. Then we can't do it just off the top of our head. I can tell you 56 is between what? 49 and 64. So I know it's more than 7 but less than 8. It's 7 and some change. That's all I can tell you. But if I want to know the exact answer, then I need a calculator. I go, clear it, here we go. 56, and where's the square root? That little hook here, let me just find it. Right here, can you see it? There's a square root button right here on mine. And it says 7 point what? 4833 and some change. So if we give you a number that's not one of those nice numbers, then you have to use a calculator. What is the square root of 12? Again, that's not one of those numbers. 12 is more than 9, less than 6, so it's 3 and some change. Let's see what the calculator says. 12, hit the square root. 3.464. What's the square root 28? 28, again, not one of those numbers. It's more than 25, less than 36, closer to 25. So it would be closer to 5, the answer. Let's see what it is. Oh, what did I say, 25? I hit 5 instead of 25. The square root, 28. The square root of that, 5.2915. So if it's not one of those perfect squares, then you have to use a calculator. Why are we interested in that? Because of this one, Pythagorean Theorem, or Pythagorean Theorem. Now, what does that theorem says? It says if you have a right triangle means you have a 90-degree angle. So let's make a 90-degree angle. Something like this. That's a right triangle. Right? That means this is the 90-degree angle. Let me call this side C, this side A, this side B. C squared equals what? A squared plus B squared. That's Pythagorean Theorem, or Pythagorean Theorem. If you ask any carpenter, when you're building a wall there, they always want to make sure the wall is square. What does that mean, square? 90-degree angle. How do they make it 90-degree angle? You're building this wall, let's say a kitchen. You got this side here, and you got that side. And you want to make sure that angle between them is, it's 90-degree angle. The easiest thing to do instead of trying to measure the angle is they go from the corner and they go 3 feet and they put a mark. I'll use inches here. It doesn't matter which side. They go one side and 3 inches, and they put, in their case they use feet. They go 3 feet or a yard, they put a mark there. From this side they go 4 feet. Let me find where the 4 inches here and put a mark here. So this is 3 and this is 4. For this to be right angle, if I did it right, the distance from that mark to this mark, it should be what? Anyone? Better be 5. 5. Ask all these carpenters. How do you know you have a right triangle? They go 3, 4, 5. If I measure that distance from here to there, look at that. Can you see it, the ruler? What is it? 5. That's how you know you have a 90-degree angle. If it's not 5, they start pushing on it to make sure that's 5. Why? Let's call that C. Because of Pythagorean Theorem, it says C squared equals A squared plus B squared. C is unknown. It doesn't matter which one you call A, which one you call B. You want to call this one A and that's B? So A is 4. That's 4 squared. B is 3. That's 3 squared. What's 4 squared? 16. What's 3 squared? 9. What do we have? 25. What number, if you multiply it by itself, is 25? 5. So C really equals the square root of 25, which is the 5. Because we said the square root says what number, if you multiply it by itself, the answer is 5. So that's one way carpenters know they have a 90-degree angle. It's called 3, 4, 5. They go one side, they measure 3 feet, this side 4 feet, and they know from that mark to this mark has to be 5 feet. If it is, you got a perfect corner. Because the only time this will be true when this is 90 degrees. If it's not 90, it's not a 5. I'll give you another example. A few years back, my father-in-law was alive, so he's been dead for about 12, 13 years. I was about to side my house. And he goes, you don't have to hire somebody. You're a young man, you can do it. I go, I never sided a house. My friend Nelson sided homes for a living, but my father-in-law was about 70, Nelson was 75. Both Irish. Nelson, I talked to Nelson, I said, you can use his equipment. So Nelson shows up with all his equipment to side my house. And him and my father-in-law sat there every day drinking. I'll buy the beer for them. They'll sit and drink and tell me what to do. I end up doing the whole house. Didn't cost me much really, except buying the beer for them. But I reached the point I was doing the back, and my house has a walkout basement. Then I got, you got the first floor, the basement, where the pool table and the hot tub and all that there. I got the first floor, which is the kitchen. Third floor, which is the bedroom. And the attic. So the back is really high. Like this. So we just say the house like this. Somewhere there. And I'm trying to side the back piece. So here's my ladder. My house right there. So I got my ladder leaning against the house. And I got really a big extension ladder. I think a 50-foot extension ladder I had. This is my ladder. And I'm trying to reach the top. And I'm barely reaching the top. So I had the ladder almost straight up against the house. And I'm going, this is insane. I'm going to tip backward. I'm going to kill myself. Because that ladder was so close to the base of the house. It's 50 feet long, that ladder. If I take and put it straight against the house, how high would it go? If I just lay it straight against the house, how high that ladder should reach? 50 feet. Now, if I move it back 10 feet from the base of the house, right here, Jim, if I move it back 10 feet, how high would it go? What do you think? The ladder is 50 feet long. I'm dragging it back 10 feet. How high would it reach?
40.
It's the common sense. Well, you move it back 10, should drop 10. Well, let's see. Pythagorean Theorem says if I call this one C, this is A, this is B. C squared equals what? A squared plus B squared. What is C equal to? 50, square it. What's A equal to? 10, square it. And B is the height. $50 squared is what? 2,500. 10 squared is 100. Now let me subtract 100 from both sides so I can isolate h squared. And now what I'm looking for is what number, if I multiply it by itself, the answer is 2,400. 40 times 40 is what? 1,600. Not close even. So the question, what is the square root of 2,400? And let me go to my calculator and see what that answer is. 2,400, take the square root of that. Ready for the answer? How high is it going to go? Almost 48 point what? 99. 49 feet high. By moving it back 10 feet, I know now it's stable.
I was going to say that because when you like this, you really don't move much. When you
Nope.
pivot it,
Yep.
just the angle.
Yeah, you move it back 10 feet, it's only going to drop 1 foot. 1. And I wasn't thinking about the math till I was standing on the top going, this is insane. I got it like 4 feet, 5 feet from the base there. I'll be honest with you, I didn't trust myself. I went on the roof, took a rope, wrapped around the chimney, threw it over. I was holding that rope around my waist, tied around my waist. Because I knew that ladder was going to flip backward when you're 4 feet away and that high. But if I moved it back 10 feet, it's more stable. I can reach and do whatever I need to do.
Yeah, because that's what you're changing the stability of it.
But people think because you're moving it 10, it's going to drop 10. That's what most of you say, it's going to drop 10. It's not linear. You can see it if I take the ruler and lay it against the wall, this board. Watch this. There's the ruler. I can mark it. Do I have a marker here? Here we go. Notice when it's straight against this, it goes this high. That's when you put it straight. Now watch if I move it like a little distance, maybe like 5 inches back. There's 5 inches. Look how much it's going to drop. That's the 5 inches. Right there. I moved it back 5 inches, dropped less than an inch. That's it. Why? Because of Pythagorean Theorem. You can use it to calculate any right triangle, meaning what? In baseball, take baseball. They play on something called 90-foot diamond. If this is home plate here, first base is 90 feet away. Second base is what? 90 feet away. Third base is 90 feet away. First, second, third base, and that's home plate. Each one is 90 foot, and the angle is 90 degrees between them. It's like a square. So when the third baseman throws the ball to the first, you go, what is that distance? How far are they throwing it? What's that distance from third to first? What is that equal to? You think it's 180, right? 90 and 90? But they're not straight line. You're not putting them like this, end to end. So Pythagorean Theorem again. This is your triangle. This is your 90-degree angle. This is your C. This is your A. This is your B. C squared equals what? A squared plus B squared. That's 90 squared plus 90 squared equals C squared. 90 squared is what? 8100. 8100. 16,200. And to get C, you take the square root of that number. And it's 127.3. So basically almost 40 feet from here to there, 40 feet more than that distance. If you throw them from home to first or third to home, that's 90 feet. But to go from third to first, it's almost 40 feet more. It depends where you are. If you're on the inside, probably 30 feet. If you're on the outside, maybe 40, 45 feet extra. So you got to have a strong arm. That's why the third baseman have like the strongest arm beside the outfielder, because that distance is longer there. Shortstop is the same thing, because shortstop has to go home a lot of times. That distance from here to there is also 127 feet. So this one and this one better have good arms.
Now I know why my arm is so messed up.
Yep, if you played. Yep, if you're a shortstop, you're throwing that distance, long distance. Yep. We can look at it too. Another example. Let's say you're standing across the river. The river is 50 feet wide. And you are right here, and you want to go right there. Well, you know that distance is 50 feet. We know this distance. Somebody told us, somebody was on the other end. They go, you know, the distance from here to there, you're trying to figure out what is that distance. But that distance here, somebody was cross, went and measured that distance, and they said, that's 30 feet. Now you're saying, I got to take my canoe and go all the way there. I'm going to point it there. Let's say it's a pond. The water's not moving, because if the water's moving, you got to worry about where you're going to shift. But let's say it's a little lake. The water's not moving. And the question is, what is that distance? S, we'll call it. How far from here to that? It's more than 50. Well, let's see. Pythagorean Theorem. It says this side squared equals a squared plus b squared. I'm looking for that. That's S. A is 50, square it. B is 30, square it. 2,500 plus 900. 3,400. What's S equal to? That looks like under 60 there. Jamie said 75. I'm saying under 60, Jamie. Let's see what that number. 3,400. Take the square root. Probably about 59, 58. Oh, error. What was it? 3,400 square root. 58.3. Yep. So instead of going straight this way, 50 feet, then walking along the sand 30 feet, that's 80 feet, why not go diagonal? You're only going 58 feet. 8 extra feet than going this way. So I'd rather just do that and land right there. You can do a lot of examples with these. Handicap ramps. You know, you're building one. There's a guideline for the handicap ramp, how high for every distance. And I think, but I'm not really sure about that, I think it has to be 12:1, the ratio. I think. Don't quote me on this. Meaning for every 12 feet, you can only rise 1 foot.
Slope on it?
Yes. That's, I think, what the law is. Mm-hmm.
Not,
Yeah, if you make it steep, they can't. You don't have the strength to push it up. If you make it like 6 to 3, good luck. That's straight up there. So if you're trying to build one, and you need to go buy a piece of wood to go from the top to the bottom, what is the length of that piece of wood? Or that could be the roof on a house. You're making a shed, and it's 12 feet wide. It goes like this. You know, that's the other side. Just to show you the other side, right? And you want to know these rafters, how long each piece is. Could be the example, anything. Handicap, roofing on a house. How long that piece will have to be. We'll go s squared equals what? 12 squared plus 1 squared. 12 squared is what? 144. 1 squared is 1. 145. So s is going to be the square root of 145, which is just a hair bigger than 12. $12.04. So if you make it 12.04 that piece, you're fine. Lots and lots of examples for them. I'll stop with this.